So what is a perpendicular bisector? And what kind of thing has a perpendicular bisector? Well, perpendicular bisectors commonly apply to lines. So if you think of this horizontal line, the perpendicular bisector is a line that's perpendicular to this line. So let's start with perpendicular line. So we have this line here. Lines are perpendicular to, I'll label this line. This line is line AB. So if you're asked to draw lines perpendicular to AB, there are many lines you can draw. The only requirement is that the lines make an angle of 90 degrees with line AB. One of these lines will be the perpendicular bisector of AB. And how do you determine that line? Well, the line is simply the one which passes through the midpoint of AB. The idea of a bisection is splitting a line into two equal parts. So have line AB, I'm drawing this again. But this time I'm going to point out the center of AB, M. So this is such that line AM, so we just move from A to M, that line is equal in length to line MB. So that a perpendicular line to AB, which passes through M, bisects AB. Therefore, this perpendicular line is a bisector of AB. So it's a perpendicular bisector of line AB. So that's the idea of a perpendicular bisector. Here we're interested in the perpendicular bisector of a chord, which you're familiar with now. So I'll just draw a chord here. So my chord joining point X and Y, where X and Y lie in the circumference of the circle. So the perpendicular bisector of chord XY is a straight line which connects the center of the circle to the midpoint of the chord. So XY has a midpoint. I'm telling you that the midpoint is this point M. This is the center of the circle. So this rule here is such that a line from the center through the midpoint is perpendicular to XY, but also bisects XY, which means that, of course, this point is point M, which means that XM is equal in length to line MY. So this is the rule. You have a circle, you have a chord. If you draw a straight line from the center of the circle through the midpoint of the chord, what you've drawn is a perpendicular bisector of the chord. How can this be useful? So I'll give you an example. I'm going to draw my own circle. And I'm going to draw my chord. I'm going to tell you that this is the center of the circle. And this is a point A. This is a point B. And OA and OB are equal to the radius of the circle. As you know, if you draw a line from the center of the circle to a point on the circumference, what you have is a line whose length is equal to the radius of the circle. Now, if I draw a perpendicular line to AB from the center of the circle, I know that that line bisects AB, because you know that a line from the center of the circle through the midpoint of a line from center of a circle to a chord which passes through the midpoint is perpendicular to the chord. Imagine if I draw a line from this center of the circle to the chord, but to any other point. This line is not perpendicular and doesn't pass through the midpoint, but the line which passes through the midpoint is always perpendicular to the chord. Alternatively, you can think of it this way: a perpendicular line to a chord always passes through the midpoint of the chord. So what I've done here is I've drawn a perpendicular line to the chord AB. So I know that that line passes through the point M, the midpoint. So this is 90 degrees, that's 90 degrees. So what I've just done is I've formed a right angle triangle. Well, I formed two right angle triangles. There's one here, the right angle triangle, and there's another one here. So what this knowledge of perpendicular bisectors allowed me to do is form a right angle triangle, and this right angle triangle that was just formed will be useful in solving problems because, well, let's just wait till the exercises, but you can see how this could be useful because what we just did is form the right angle triangle. So say you are given this angle, say it was 30 degrees, just because you know that this is now well, this is a perpendicular bisector, you can work out the length of AB. How? Well, let's say you were given the radius of the circle. Say the radius was some value. Now, from SOHCAHTOA, you can easily work out. So I'll take it slowly. From SOHCAHTOA, so let's say R is 10 centimeters. The value doesn't really matter here. What I'm focusing on is the concept. From SOHCAHTOA, you can easily work out the length of AM. I'll do that here actually. So let's see, sine, cosine, tangent, sine, cosine. Cosine works here. So the cosine, this angle here is 30 degrees. So I'm focusing on this right angle triangle here. From this right angle triangle, you know that the cosine of 30 degrees from SOHCAHTOA is equal to the length of the adjacent side, so AM, divided by the length of the hypotenuse. I should use black, which means that the length of AM is equal to 10 times the cosine of 30 degrees. This is something you can work out in your calculator. So we've all of a sudden worked out the length of AM. What if you're interested in finding the length of AB? Well, because you know that the perpendicular bisector, so OM, splits AB into two equal parts, you know that AM is equal to MB. So you now know that MB is equal to AM. So MB is also equal to 10 cos 30. So AB, I'm just jumping around now, the length of AB is simply equal to 2 times the length of AM, which is 2 times 10 times the cosine of 30 degrees. So this is how this knowledge can be useful. So you just find different problems where your knowledge of this will help you form right angle triangles, and it then allows you to use things like SOHCAHTOA and Pythagoras' theorem to simplify problems.